么意思？
连接。
你看一下而已。
This one。
对你可以不用打开它的界面，你就是直接切换对。一般这样啊，一般你刚开始不是这样，对，导过去看一下，看稍微动一下，然后代表它都已经有一点的移动，然后就可以开始跟你讲，对。对，然后我现在先预约一个小儿童，然后
你等一会儿，我先直播没关系哈。
等一会儿3点半的。
好。
马上就可以。
比如说我可以约，就下1分钟我就要开始了。
对呀，他只是7分钟而已，然后什么时间是你他只说开在那边，然后这边有个场，然后想什么东西都是你的场。
好，那我就等一会儿哈。
我这个直接弄一下就行是吗？好。我试一下。
对，然后就是一个东西就是提前嘛，你提前一段时间你要先测试一下你的声音。你要先测试一下你的麦。
我听得到吗？
测试麦的话，一般是打开那个麦克风。比如说最左边，设置第3个，然后选择那个有没有个声音第1个声音系统，左边第2个声音，等一下。对，然后现在它是麦克风，我们主要测试麦克风。你现在讲话。
Hello, how are you？
这个要先测试，然后这个就可以。
OK。
可以先把这个关掉。
没
在测试。
没事，测试。
对，然后。
不会，你在开会吗？你录嘛？
对，这个要全屏。
或者你去另外一个房间录。
对，这个要全屏，然后 tap 进去，就不用再去点，然后直接这样可以直接看。对，然后可以放到 PPT， 放到 PPT 那边继续讲。PPT。
用耳机讲，算了，我随便讲一讲，反正你们要配你们自己的声音。
Hello everyone。
对，你的头像什么东西要先调，然后再导到 PPT 去讲。好，也是 Tab 键。
Yeah, hello everyone. Today we would like to share the global league broadcast with you. Today's topic is 1064 nanometers Raman spectrometers, and we would like to introduce the advantages and application of 1064. And this PPT is translated by Freya Wan and live broadcast by me. As we all know that 1064 nanometers Raman spectrometers are very have some advantages and applications. So you may wonder why it's needed to use the 1064 nanometers Raman spectrometers. And so in today's PPT, we will share these knowledges with you from the following 5 parts. 你可以回去，没关系。他这样小儿童 ，OK. And part 1 is the traditional existing problems, and the secondary is the advantages of 1064 nanometers Raman spectrometers. And part 3, we would like to introduce the Optosky manufactured 1064 Raman spectrometers models. And part 4, we are going to introduce the 1064 nanometers Raman spectrometers application cases. And part 5, we are going to introduce the company's profile. Again, we would like to introduce the Raman spectroscopy principle. Firstly, you can see the Raman. Raman was Raman is an Indian scientist. In the year 1928, he discovered the Raman phenomenon, and in year 1930s, he received Nobel Prize for this discovery. And secondary, we can see it from this. You can see it from this sketches. You can see that this is the Rayleigh scattering, and this is the Stokes lines, and this is the anti-Stokes lines. And the Raman is used to identify the Stokes line, and we will use filters to. We will use the filters to long pass filter to filter the Stokes lines and Rayleigh scattering and left Stokes lines. And this is the Raman spectrometer's principle. You can see we can see that Raman spectrometer is made up of three components. First is the spectrometers, and secondary is the laser, narrow light bands laser, and thirdly is the Raman probe. So firstly, you can have a laser shoots on the line to shoot on the collimating, shoot on the slitting slice, and shoot on the collimating lens to collimate the lines, and go to focus lens and shoot on the sample. The sample will generate the scattering lines, and here will reflect the lines to here and go through the long pass filters, and you can focus on this coupling lens and access to the spectrometers to make analysis of the scattering light. So you can see from here is the classical components of the Raman spectrometers. They are the ATR 2007 spectrometers, and secondary is the laser, and thirdly is the probe. So in our Raman spectrometers, the main components composed of these three main parts. And secondary, then we would like to introduce Raman applications. Raman application and core competitions and optosky's core competition. Raman spectrometers are applied to biomedicine, such as it can use to detect early detection of cancer, and also it can identify the change in actual structures of biomolecules, and also used to identify calculate analysis. And also, we can see the pharmaceutical industries, pharmaceutical analysis, drug scans, and crystallization process monitoring, and raw materials validations. And also need to mention public safety. Public safety used to identify the narcotics, drugs, and also fast detect explosives and flammable materials and toxic hazardous materials, and also used to detect poisoners. And for food safety, they are widely used to detect pesticides residues and some food additives and contaminants. Also, it's a notorious refined garlic oil. And for the fifth is environmental science. We have the wastewater contaminations and petrol analysis and deposit analysis. And last one is the gemstone. It can identify the gems and trace the place of origin, anti-counterfeiting, and anti-identification. Optosky has 20 years experience in developing Raman spectrometer, not only because we are a national standard drafter for Raman spectrometers, and we also have the most full range of the Raman spectrometers covering from the 266 to 1064, and there's the Raman spectrometer manufacturer for 1064. And the third one is in 2016, we launched the first high sensitivity handheld Raman spectrometers. Also in 17 launched the dual band Raman spectrometers. This makes us one of the two manufacturers in the world who can manufacture two dual band Raman spectrometers, and we also have the three band Raman spectrometers, and that will break the records in the world. And also we have the high reliability instruments, and also have a quantitative algorithm. So Optosky are quite professional Raman spectrometer manufacturers, and have been developed in these areas for very long time. And we have we would like to introduce the common wavelength length existing problems. Here you can see that it is the alcoholic Raman signals. This alcoholic Raman signals has distinctive shapes. Yeah, it has distinctive shapes. You can identify this is the alcoholics by the spectrum. However, beer, they are composed alcoholic, and but if you use the Raman spectrometers to identify, you can see that it has only a small peak, whereas other peaks hide it. That's because there's a strong fluorescence hidden the other peaks. So we express these phenomena as the little rotters just appears little peak. So other peaks are hidden. This is the common existing problems of high fluorescence could hidden the Raman signal. Raman signal is interfered by fluorescence, like this one, and you can see that fluorescence intensity is about millions times stronger than that of Raman signal. So traditional Raman signals are easily interfered by the fluorescence. You can see heroin and fentanyls has the high fluorescence, and color samples, and also biological samples like textiles, bacterials, and drugs, and also fuel and petrol samples, and vegetable oils, and explosives, and plastics. All these materials have high fluorescence. And we can see that 1064 nanometers Raman spectrometers can resist fluorescence generation. The near infrared photon has low frequencies. So low frequencies is seldom absorbed by sample molecules. So in ground state, electron is difficult to be excited. Fluorescence is difficult to be excited. As a result, 1064 nanometers Raman spectrometers can now generates fluorescence, and it can resist fluorescence. So this is the big fluorescence background. It's now appeared. So if you use 1064 nanometers Raman spectrometer, the shifts is distinctive, like these rotors can finally grow. How to next we would like to introduce how to remove fluorescence background. Firstly, we would like to introduce a baseline correction. Baseline correction is by using algorithm can remove fluorescence background. Most optosky have the these basic configurations for all Raman spectrometers because it just needed to use algorithm and it did not involve any cost. But the disadvantages of baseline correction is application is relatively limited, and you can see the problems of baseline correction. This is the Raman signal, and you can see this one is the fluorescence. And after optosky baseline correction to remove the background fluorescence, you can see this the blue Raman signal. The curve is shaped distinctive and good. And then, however, if there's no peak, if this one should have a peak, but it didn't appear. After baseline correction, the peaks also collapse. So if only single peak appears, can use baseline correction to export nice Raman spectrum. Those in some areas do not have a peak or being overlapped by fluorescence background, it can cause peak loss. Also, you can see this one. The disadvantage is the weak signal intensity and small. So the dynamic range is very small dynamic range. So we say that baseline correction could cause peak loss and weak signal intensity and small dynamic range. The second method is the difference operation. Fluorescence background do not shift with different excitation frequency. By using two adjacent wavelengths of laser, such as 1084.5 to and 785.5 nanometer to excite samples, can obtain two group-of signals. After differences of operations left only Raman spectrum. It just need to use two lasers. Laser cost is relatively not high, so the advantage is cost is acceptable. However, like the baseline correction, it could cause peak loss and it have low resolution, and it used the two spectrum to use the algorithm to deduct, so it could have a bigger noise, and after deductions, the shifts could be uneven. Maybe if the left like this one, it could be like this one. So it could be just the left is high and right is low. So it's the unstable baseline. After the deduction, the baseline is unstable and cause a shake in a mass. And also we have 1060 Raman spectrometers can be used to remove the fluorescence background, because as we introduced before, near infrared photons cannot be absorbed. So fluorescence cannot be generated in mechanically resist the fluorescence. It resists the fluorescence generation, so it has many advantages. However, it has to use the INGA sensors. It needs to cool down to -20 degrees, so the cost is very high. And also, it causes the problems of larger power consumption. And the 1064 has low frequencies, and the dictate time is longer. It's needed 30 to 40 seconds, so compared to 785. And also we have other methods of such as the time gain control. Because we all know that if we have sensors, the fluorescence signals will be appears in just nanoseconds, and Raman signals will appear in the microseconds. So we have time differences here. We need to install a shutter here to deduct the fluorescence and left the Raman signal. So it costs over 1 million RMB. And also we have fluorescence can use the photo bleaching methods, but it takes at least half the time. Some people cannot wait so long, so it's also very time consuming for the photo bleaching. This is OptoSky 1064 nanometers Raman spectrometer series. We can see that this is the most popular handheld Raman spectrometers, and this is our Raman microscope. Can make it 1064, and this is a portable handheld Raman analyzer, and also we have a desktop Raman spectrometers. And next, we would like to introduce some details about ATF6600. ATF6600 is the 1064 handheld Raman analyzer, and it features because OptoSky is the exclusive provider of 1064 Raman spectrometers in China, and we have a C certificate. We are the only manufacturer receive the policy certificate, and also we have a 1019 war military guns. And our features is use the 1064 nanometers laser. It can reduce fluorescence, and it's a non-detective, and it can fast detect and identification. It just needs a one-button operation and use the advanced algorithm and dictate. It can detect the mixture. It not only can detect the mixture and can show the percentages, and also we have the high definitions, the 5.5 inches touch screen, and it's super to operate. We use the 13 mega high definition camera, and it can sparkle scan and use the GPS positioning, and we have the 4G, GSM, and GPS, RS, and Bluetooth, Wi-Fi, multi-mode. We can self-build libraries and detect results, report, create, and export. You can build in Lee factory span, and also lightweight. It's only 1.2 kilograms, and also easy to take to anywhere. We have the IP67, and it applies to many applications like police narcotics drug identification like heroin and fentanyls. And we also use the pharmaceutical industries like to identify raw materials and excipients. And our instruments can well compliant CFR 21st compliance, and also can provide IQ, PQ, OQ compliance. And also, after introducing the ATR 6600, we can also introduce the accessories. ATR handheld Raman spectrometers can be used to detect liquid, solid, and also powder, and can detect through the transparent or semi-transparent plastic bag bottles and other packings. And we have the ATR 8300 autofocus Raman microscope, and it also have the 1064 nanometers. So this Raman microscope instruments are the exclusive miniature Raman spectrometer with mapping functions. It realizes the true confocus, and it can fully automatic and autofocus and auto scan, and it has no moving components to make the switch pass. So the performance stability is high, and performance is excellent. And also we use the 5 mega cameras, so images is very clear. And excitation wavelengths, we use 2 nanoparticles and also new materials. So we can also identify science research institutions, biosciences, and fluorescence identification, and material science. And we use to medical immunology analysis and agriculture and food accreditation and gemstones and mineral identification. This is our poster for Raman microscope. We have the autofocus, auto scan, high sensitivity, high definition imaging, easy to move, and suitable for all environment. We can manufacture 1064 A30 nanometers, 785 nanometers, and 63030 and 532 nanometers. And we have 3 types. We have a basic type, use the manual control, and we have auto type, and have a mapping type. And also we have the 500 megahertz imaging and real-time focus, and we have a 2D scan, and 3 objective lens can be optional. And also use the deep port T-Sync CCD, and the reliability is high. It's designed without move parts, no need frequent calibrations, so it can suit to various applications. Next, we would like to introduce our most advanced software, that is the human-machine interface. This is the interface of the Raman microscope. These areas is used to. This area is camera windows, and this one is show the spectrum display areas. And also we have the here is the Raman imaging area. You can just click this one. It can show the intensity changes. Maybe the concentration here is that bigger concentration and less concentration, and this one is concentration is smaller. And also, if this it shows this connect, it shows the connect online. If it's disconnect, it will show red. And also we have the data, raw data, and dark data, and also deduct the background data. And this you can click different spectrum, and you can see here is the peak, show different peak point. And also here you will see the material test result. Which material is this? And also we have ATR 83 ATR Raman microscope used to search this embroiled metal rings, and this is the spectrum. And also we can have ATR 3064 portable Raman analyzer. The feature is it uses the Android system. It has the 11.6 inches touch screen, and resolution is 11 centimeters, and the wavelength is 200 to 2600 centimeters. And we have the two-stage TEC port with a high signal to noise ratio. And excitation wavelength is optional. And we have the 785, 1064, and 532. And also have the all this we have the 1064 and weight 7.5 kilogram and car mode. And we have the portable 1064 Raman analyzer. And this is the raw filtrate spectrum. Raw filtrate spectrum. It uses the 1064 signal. It's very good. And if you use 785, the signal is very weak. And also we have the scientific research 1064 nanometers Raman spectrometer. And resolution is the same, and wavelength is 200 to 2600 centimeters, and it uses the two-stage TEC port, and it uses the USB 2.2. Wave倒退退后，我现在人不在，我现在人不在。 and you can see that it uses the USB 2.0 interface, and it can use the full functions PC, all function the PC software is the most advanced, and it has many functions, and the weight is 5.5 about 5 kilogram. And also you can see ATR 3110 1064 spectrum review. You can see this is the acetonitrile, and it uses the laser 300 microwatts, and integration time is 10 seconds. And we also have Theranode, and also you can see Raman spectrometers has been used to identify narcotic drugs, and used to identify liquid and food safety, and also we can identify some pharmaceutical drugs, drumsticks, and plastics. Why we use the Raman spectrometer? Because the Raman spectrum is like the fingerprint of the material, so it's very accurate, and it just takes few seconds, so it's very rapid test. And also it just need to shoot the weak laser to the sample surface is non-detective, and it did not need to prepare samples and non-consumable accessories, so it's low cost. And the 1064 nanometers Raman apply to also narcotic drugs and pharmaceutical drugs, and for scientific in lab, and also in food safety for the pesticide and petrol, and also some drumsticks and archaeologists. Raman spectrometers apply to public safety. When we see from these explosive cars, we know that it's needed to identify explosives and flammable and hazardous materials or liquid before the entrance of the metro, like metro, airport, like a BRT, and the concert entrance, sports entrance, and large public places. And we have a government, court, police, and also in jail. And court, you see why court? Because if some people they are not satisfied with the court, not satisfied with the result, and they could risking himself. They could kill himself, and if they take some if they take some toxic substance, he could kill himself. And also in jail, we need to ensure the safety of these places. And also you can see that in metro, in Beijing, Chengdu, Guangzhou, Xiamen, detect hazardous liquid use Raman spectrometers, and also Raman spectrometers also used to in the 2018 BRICS summit to keep safety, and we can use to narcotic drugs and precursor, and when police arrest a narcotic drug dealer, I just need to identify with our Raman spectrometer and it also in field criminal investigation and illegal factory check, and it apply to drug enforcement administration and customs and entry and exits, and used for armed police and border defense, and used for fire brigade and for court and jail, as we mentioned before. And the fentanyl dictate is very popular dictate in the police identification, because fentanyl have a many categories. So if we can use the Raman spectrometer to field criminal investigation and use illegal factory check, it can force drugs enforcement, and for customs entry and exit, armed police and border defenses. All these industries can apply 1064 nanometer Raman spectrometer. And also, we use for hazardous materials application, like we mentioned before, narcotic drug dealer, arrest scene, and drug dictate, and also when the drug suckers to identify his if he hit some belongings, if he take some drug suckers, if he has the any narcotic drugs, so Raman spectrometers can be used in public security for security drugs and drug screening dictate, and online create dictate report every time, and used to customs entries, vehicle samplings, in-field sampling test, and drugs liquid sampling test, and customs entry, passengers field inspection, customs entry, vehicle sampling, and used to in the customs and the court procurate and jail, and the court entry security inspect, jail entry security inspect should not take in pesticide, drug, or explosives to in order to ensure the security. And also we have a big event security inspect, and we have a metro high speed train liquid inspect, and also we use to defend for explosive check and drug checks, all this. And then 1064 nanometers Raman for narcotics arrest. We used to dictate heroin and methamphetamine. Methamphetamine. This is the spectrum. The blue one is used the 785. Raman spectrometer, you can see that this spectrum has a big fluorescence background. Raman signals can now appear. And if you use 1064 nanometers Raman, the Raman signal is very vivid, distinct. At least one is here lying. So this is the ATR 6600 used to in the field of police to identify heroin and fentanyl. Also, we can use the 1064 drug arrest application. It's the chloroferdrin spectrum. And we have the 1064 nanometers Raman for spontaneous and here I int detect. You can see this 1064 nanometer detect spectrum, and the above spectrum exported by ATR 301064 is our first generation signal. It's such good, and now we have upgraded to the third generation, so performance is higher and is 3 times higher signal to noise ratio. And also we have the Raman spectroscopy applied to pharmaceutical engineer, and we have a pharmaceutical drugs production safety FDA, and also we use the European pharmacopoeia and the Chinese pharmacopoeia. And this is all Raman spectrometer's advantages. As we all know that technology, there are 3 different types of technology used to detect raw material and excipients. HPLC, high efficient, but it's very large and time consuming. And we have the FTIR, and for Raman spectrometers. The advantage is Raman spectrometers cost less. Raman spectrometers cost less and it's durable to use. It's very easy to take and operate. It just a few hundreds of grams and no need sample preparation, and the accuracy stable, and the Raman is a fingerprint of raw material. It can export accurate results, and it can identify solid, liquid, powder, inorganic. We have dictate time, it's fast. The pharmaceutical industry also uses 1064 nanometers Raman spectrometers, such as the Raman spectrum canal material structure. And you can see this is the 532, blue one, and the 785, the red one, and 1064. We can see 1064, the Raman spectrum is vivid, and for a pharmaceutical Raman spectrum can know material structure, and we can know the ingredient and function group. They are Raman spectra of a material and easy to detect and can distinguish different pharmaceutical ingredients. And we also have the 1064 Raman spectrometer to detect the capsule Raman. The blue one is 785 with a big fluorescence. It's 1064 with a vivid spectrum. 785 is hidden by strong fluorescences, but 1064 has distinct shape, can identify glucose peak, And also we have a 1064 nanometers Raman spectrometer applied to detect drugs. And this is the drug sorbitol, sodium benzoate, and the piracetam. And all this is the used to identify. You compare 1064 versus 10785 is a Raman spectrum comparison. Aminosynucleic acid